So, konnichiwa, good morning everybody. It's truly an honor to be here with you, with security professionals here at Code Blue conference. So, my name is Alexander Rodchenko, and I work at Kaspersky Lab at Security Research Department at SOC. So, today's agenda, today's purpose of my presentations is to demonstrate the necessity of existing SOC at all modern companies. I believe that SOC is really important. I figure out several practical cases, and I also try to give you some classifications of modern problems that SOC designed to solve. Only SOC can solve some modern problems. To understand everything, we must figure out the relationships between classical security products and SOC. Classical security products like antiviruses, like firewalls, focus on productivity and prevention. And it's obvious, antivirus prevents some attack. Also, that classical tools heavily rely on signatures, patterns. They detect known threats, only existing, well-known threats. But SOC prioritize the context of whole infrastructure of your company. SOC tries to operate with adaptive methods, try to operate the telemetry and detect some anomalies in general. But any cases, SOC relies on classical tools. But SOC, it's the thing that try to unite, try to reach all information together from the all of your company. So how I reach the main purposes? How I can figure out that SOC is necessary. So Gandalf once warned Saruman against simplify things. He told that he that breaks a thing into pieces to find what it is has left the path of wisdom. Following that idea, we start from some cases that really exist, and after that we figure out the whole conception. We start from small thing and go into understanding of everything. So let's start. And we are starting from one of the one of the strongest things to understanding the golden ticket. And I try to describe that detect of golden ticket. It's typically SOC thing. So let's figure out with just Kerber's definition. So it's a picture from Wikipedia. Let's recall how it looks like. Kerberos is a three-party protocol between client, server, and third trusting point, key distribution center. The whole security ensures that key distribution center has not been compromised. The KRBTGT has not been compromised. If it's true, that means that Kerberos is reliable, everything is okay. But in real life, some bad guys stole KRBTGT cache and everything goes wrong. So, look at Kerberos authentication flow in general. The first, some user tries to ask for TGT. It ensures that user is user. He uses its password timestamp and asks at KDC the TGT. If everything okay, TGT comes back to user. After a while, user decides to go to some service. And to use in service, you need another ticket, TGS. And user asks TGS on KDC, and to ensure that user is user, TGT also applied. Everything okay, TGS coming to privileged user in our picture. And that ticket was forwarded to Kerberos enabled service, TGS ticket, and everything okay, and service was allowed. So, let's go deeper and imagine that KRB TGT was compromised. What happened? The first two steps where the user asked TGT disappears. Just because user, in our case is attacker, just generate its own TGT and offer it to KDC to ask TGS. After following definitely the same. So, we should bring more context, more real life. We want to start CMD via PSExec. Everyone knows what is PSExec, yeah? Used it. So, process CMD.exe must be started. Process cannot exist without user session. Process runs on the user session. So, user session must be. Also, every user session has its own primary token. Token must exist. Okay. To start user session, we must add TGT to service. TGT must be forwarded to Kerberos enable service. Okay, okay. And also to use SCM service, PSExec uses that service to start service itself. TGS service ticket must be provided too. So TGT token TGS appears at in our case at client side. Okay. We don't currently know how, but we must figure out that user session and its associated token are primary evidence of using golden ticket, just because it costs by golden ticket. Token, session are evidence. Just remember that. So, we are going step back and imagine that we are attackers. We are attackers, we stole KRB TGT and want to create golden ticket. So we are open Google and Google how to create golden ticket. So, and definitely almost all instruction at the all entry of internet give you exactly one advice. Just put your KRB TGT hash inside some template, inside Mimikatz Kerberos golden command. And yes, definitely, everything working. You create absolutely working golden ticket, and after creation, it passed into session, and you create a PSExec on remote machine using that golden ticket. Everything works. So, also, while created golden ticket, I should notify you that some default Mimikatz patterns, Mimikatz evidence appears just inside that screen. Just remember exactly that numbers. 500 and etc. under group ID section. 5 numbers. So, we are speaking about token. We created process, session, and also token exists. So looks like it's a token. It's a token that was created by golden ticket. Look at that. And look, there is definitely the same token groups exist on token. The same groups that was defined but by mimikatz. Seems interesting, but oblivious, yeah? Mimikatz defines group membership. Group membership appears at token. But what about the real group membership at administrator? Just imagine we are on real environment. So, and how it looks like with normal authentication flow when administrators log on and start some process. How looks like its normal token? That's like. It differs significantly. And we can, I think, detect it. It's really significant differences. And yes, we see the difference, but it's not clear why it happens. So, it happens just because of PAC. So, PAC, it's a privilege attribute certificate that is a part of Kerberos protocol, but it was developed by Microsoft and extends the Kerberos protocol. Microsoft developed that private part that was signed by KRB TGT hash also to several purposes. Also, Microsoft include the group membership on that pack to do its life more easier. And really, they put group membership into pack, and when LSAS authorized user, LSAS just copy group membership from pack and put that group membership directly to token. The same order, if you know. And it's oblivious, and it's working great, but we know that in our case, pack was forged by mimikatz. Pack was forged by mimikatz. And in real life, group membership differs from default mimikatz generated. So, I write a tool that that just verifies real group membership of particular user with provided tokens, with provided group membership on its token. Yes, it's quite oblivious way, and you also can share, use, reuse, implement, I don't know, do whatever you want with my code. It's just quite simple. It's just comparison between two lists, two tables. So, but I want to notify you, put your attention at, to do that detection logic, we just compare information from one information system with other. I forget which service exists on comparing information from the whole information structure. It's typically the SOC task. SOC correlates data. SOC works around the whole data, including Active Directory and, for example, token group membership. That's why detecting golden tickets that way, it's typically SOC task. Yes, it's my opinion. So, let's go over and let's discuss about SCCM. what is SCCM and how it looks like and how it's working. Generally, SCCM is Microsoft developing system that managed, generally it managed anything, but it developed to manage Windows machines, and SCCM do the following task. Guys, just you should understand that SCCM can do whatever you want. SCCM is extremely honey target. Just know it and enough. Also imagine the red guys, red teamers invent the dedicated attack matrix to attack SCCM specifically. That's why SCCM must be monitored. So how SCCM looks like? So that slide simplified illustrate the diagram of workflow inside SCCM. Everything, almost everything stores inside server database. But all actionable executing objects of SCCM side server are working as VMI instances of several classes and consume information from clients, put information to SQL, consume information from SQL, put information to clients. The same works at client side. VMI instances, working VMI instances, consume information from SCCM server and apply configuration, apply deployments, apply whatever you want. So, how monitor that? As I told above, everything, almost everything, stores in SQL. And there is really a dummy but effective way. We can create full SQL dump of SCCM database, perform attack or wait some changes, after that create SQL dump again, compare, and find in differences what exactly happens. Great approach, it's working approach, definitely, but SCCM side server database extremely huge. The relation between databases are complicated. And also we cannot enrich the continuous monitoring, real-time monitoring. Real-time monitoring, SQL, real-time monitoring. We can create SQL trigger. Yes, we can create, but SQL trigger must put some data to some system that notify us. We also must investigate the relationships in database. From my point of view, it's like over-engineering. That's why I can illustrate, for example, the first approach, just to prove my words. I create a full dump, deploy the task that ping Google.com on all systems, create the full dump again, find the differences, and put that differences into Elasticsearch. I put it to find one thing. Where is it my malware ping Google.com command located, stored? And I see that it's stored under document store at several rows and as embedding XML document. It's awful. It's really crazy. I cannot find what does it mean. I see the malware command, but I cannot figure out where the deployment I defined, where is the client of that deployment, who created the deployment. Awful. That's why I decided to create another approach. As I told you before, everything actionable stores as VMI interfaces. And what we should do? We can create a VMI subscription that monitor the interesting VMI classes while its creation. And it really looks simple. It's generally it's like the whole code. So, and how it's like? I create a tool called SCCM info. It after discovers the current SCCM site server, connects, monitor, and after we define some malicious deployment, in our case, in Google.com, immediately in our application we receive information like a callback. What exactly happens immediately? It's just email subscription works like. You also can use that tool any way you want, distribute, consume, I don't know, implement in your SOCs, but I also want to notify several moments. The SCCM server, it's such kind of system that can store, we can define some malware in one side at the SCCM server, but that malware can be executed at another part, another system. So, one kind of malware, but stores and implemented, defined in one system, executes another. Two systems in a row, and so which kind of services monitor more than one hosts? Definitely the SOC. It's a typical SOC objective, typical SOC problem. So in the final one, to, I don't know, be more understandable, I just want to figure out for you how it really looks like on practical examples. Just examples, just SOC reports that we distribute to our clients. So, the first example, what we can see? We can see that accidentally we find running Cloudflare services. In that case, it's a malware. It's not a malware. It's a evidence of attackers doing. Just because it forwards to the internet, in our case, it's a RDP port. Yeah. So classical security tools cannot figure out what exactly happens, but SOC analyst really can do that. And can do it easily. That's why sometimes we can see the difficulties that automated tool cannot detect by design. Only, I don't know, user can find it. Also, for example, in that case, we just see the evidence of shadow broker's leak. Oh, it's really awful. Automated tools told to us. But in brief analysis, we can find that it's not a point. So, SOC can find the significance of some type of attack. SOC can find what is really important and what are not. It's only SOC can do, only SOC. And my favorite, I think, it's just a title. It's only title. It's you see that only in the name when you receive some letter, but the first word, APT. SOC can prioritize everything. SOC can, and its basic SOC function. SOC can prioritize. SOC can differ the malware from APT, and you look at APT. And the last word, 3 hosts. Yes, it's quite simple. It's not impressive. 3 hosts, but if you use only classical solutions, you receive 3 tickets in a row. Only SOC can aggregate anything, and it's really easy. Also, SOC can explain things, explain anything. In that case, for example, accidentally PowerShell, malicious PowerShell was started. What exactly happens? In that case, in great environments, the incident response team must go to the host. But SOC can see what the user do before the execution, and it's not really tricky. Just SOC can inform you that user was a victim of some fake captcha, and it's generally like okay. So, but only SOC can explain that. So, conclusions. Generally, it's one conclusion. Just implement or build your own SOC. SOC, it's really important. Just because SOC can explain everything, SOC can solve problems that no only automated system could do. It's main. So, also SOC brings like complex system. SOC brings new qualitative characteristics that you can never see before. For example, you can reach the time of reaction. You can see the completeness of vision after you implement SOC. SOC really makes your life easier. Just implement it and you feel how it's much more simpler. And also it's just cool. SOC puts the level of technology into a new level. You can consume not only IPs, not only, I don't know, hashes, you can consume the TTPs, the tactic of attackers, and figure out, is there something in your infrastructure? So, it's all. And questions. I also prepare 2 gifts for the 2 most interesting questions. So, questions, welcome. Definitely SOC must correlate some things. And if you hear correlation, you must implement some CM. Yes, every SOC should, maybe, must use CM. CM, it's not my particular theme, but yes, I use CMs. Every SOC uses CMs, but I just skip any CM theme from my presentation. But yes, it's correct questions. SOC, my opinion, cannot exist without CM.
So the rules, do you like? So does that imply every SOC picks their own rules? The CM or like whatever correlation rule you use? Is that a secret like ingredient you use? Or?
It's another important theme. Another important thing that should be discussed, but at another maybe conference. Yes, I think that every reliable, every good SOC must implement threat intelligence inside SOC. Threat intelligence, not all over the world threat intelligence, but for example, threat intelligence inside your company. You must find which system are affected by some vulnerabilities. You can imagine what happens if you can borrow the, I don't know, some best practices and implement it. And it's all called threat intelligence. And yes, it must be in SOC, every SOC. I believe that.